All right, well, today's lesson 1.3, what we're going to do is we're going to take a look at midpoints. And if you recall, what we've been doing is we've been looking at the last few days how to find the distance of a segment and even what a segment is, right? So we take part of a line, we can measure the distance. We could find out how long it is. We could do that with the ruler, but we could also use that using the distance formula to help us. And today we're going to talk about how to find the midpoint on a segment and basically how to locate where that coordinate is on a graph as well. So we'll jump in a little bit of vocabulary for us as we start this off. So a midpoint of a segment, and I really like this one. We've been talking about words a lot lately. This is a point. Remember, this is how I abbreviate the word point here. A point in the middle. All right, this is the very informal definition, and I think we understand like that midpoint. Really, if I was to be very formal, okay, if I was to give you a really formal definition, it is a, sorry, that's not erasing right now for some reason. So, it is a point, we'll call it M, is a midpoint of a segment. So M is the midpoint of, we'll say PQ, segment PQ, if M is between P and Q, and PM, the segment PM is congruent to the segment MQ. Basically, here's your picture. Here's P, here's Q. M is the midpoint if it breaks it into two equal parts. And I think that makes sense. If it's right in the middle, and I were to take something, here's a very good example. This would be the middle, and if I break it in half, these two things are equal. And I even said I break it in half, right? So we understand these two halves are equal. That's really important for us. And we also have this other definition, and I want to make sure, segment bisector. A segment bisector is a segment that bisects, a line array that bisects a segment. And so to bisect something, bi means two, and sect is parts. Okay, or to cut. If you think of in science, if you've ever done a dissection, to break, to cut. So two cuts or two parts. So a segment bisector is something that cuts a segment into two equal parts. This point is where the segment bisector would be. Let's color this really quick. We'll say this is blue. So if I drew a line going through here, this blue line is the segment bisector. It's intersecting segment PQ at point M, which happens to be the midpoint. You can kind of see how these all go together. All right, now mathematically, what we can do is find the point or the coordinate of where that is. So on a number line, to find the midpoint, all you would do is actually take the average. If I want to know what's right in the middle of two numbers, let's say we put some numbers up here, 10 and 20, I think you all know the answer like that. You're like, oh, that's 15. Well, an easy way to see that works is you're taking 10 plus 20 and dividing by 2. And you end up with 15, right? 30 divided by 2 is 15. So that would be the midpoint, all right? So this is how you would do that on the number line. I think you guys know another name for this. If you have 2 points and you add them together and divide by 2, that's the same as finding the average. I feel like I'm on like a Sesame Street show, you know, where they like Dora, this is not Sesame Street, but like Dora will say something and then she's quiet and pretends like the audience responds, right? So I think you guys know that pretty well, all right? All right, so an example here. This is kind of word problems and we'll see some of these from time to time, but Marco places a couch so that the end is perpendicular and 2.5 feet away from the wall, okay? the couch is 90 inches wide. How far is the midpoint of the couch back from the wall? So you've got this idea. Here's the wall corner. Okay, it's 2.5 feet away, and then you've got your couch. And this is 90, and I want to be careful. This is inches, but this was 2.5 feet. So if I change this to inches, okay, 2 feet is 24. Half of a foot is 30. So we've got 30 inches here. Okay, and so it says how far is the midpoint? Well, if the whole thing is 90, the midpoint of that, right in the middle, will be 45. It breaks it into 2 equal parts. You got 45 on both sides. So the question, how far is the midpoint back to the wall this way? Okay, well, you have 45 plus 30, which is 75 inches. So you really, some of these, again, I think the beautiful thing about geometry for us is a lot of what we're doing is just thinking really carefully about the context they're giving us and applying that. And a lot of times it's real three-dimensional space that we would live in, thinking how to use that. All right. The length of a drag racing strip is 1 mile long. Sorry, I should say a mile long. I apologize. How many feet from the finish line is the midpoint of the race? Well, if it's 1 mile, that would be 5,280 feet. So the midpoint would be half of that. And again, I think this is a situation, you guys can do the math. This is something I would kind of expect at this point. You would know 1 mile is 5,280 feet. If you didn't know that, you could easily look that up online. But there's going to be times in class, in your homework, where they're going to ask you for some conversions. And either you've seen them before, or if you did a quick search, you'd be able to figure out what those are. So don't hesitate to do that if you see a problem like this. Make sure you're paying attention to those dimensions as you do some of these. All right, now on a graph, the midpoint formula, like there's a lot going on here, but it's very simple, okay? Think of it this way, and again, you can kind of see what's happening a little bit as they're trying to divide it up. On a graph, we always have an ordered pair, an x and a y. And so what they're really doing is they're looking at the x-coordinate, which tells you left and right. So you see I'm kind of trying to draw it this way. And it figures out where's the midpoint of that, which would be this location here. And they're like, well, then do the same thing for your y's. Find the midpoint of those, which would be this guy here. And then you're going to get that. And so when those come together, you're going to have kind of this middle ground. Okay? And all you're doing is the same math where you add the two values together and divide by 2. You do that for the x's, and then you do that for the y's, and then you get a midpoint. Remember that it is a midpoint. And so if you're giving me a point on a graph, it has to be an ordered pair, an x and a y. All right? So if I gave you something like this and I said, find the midpoint, that's what they want. Find the coordinates of m, the midpoint. All I'm going to do is take my x values and add those together. 8 plus negative 14 divided by 2. And then I'm going to do the same thing for the y values. Negative 6 plus 12 divided by 2. And when I do the math, this is going to give me an ordered pair, and I'll be able to solve. So 8 plus negative 14 is negative 6 divided by 2, which is negative 3. And this is a positive 6 divided by 2, which is a positive 3. Okay? Now you can always graph these, and sometimes it's easy to look at a graph and tell that way. In fact, I don't think I have an example on here. Let me put up an example on a graph here. Instead of saying, you try, let's do this one by graph. Okay? Grab a graph from my stuff here. All right? So we've got a nice little graph for us. Now let me show you a different way. If these are graphed, how could we do these? So negative 2, 3, 1, 2, 3. And negative 8, 1, 2, 3, 4, 5, 6, 7, 8. Negative 9, 1, 2, 3, 4, 5, 6. Sorry. 8, 1, 2, 3, 4, 5, 6. If I did that right. 1, 2, 3, 4, 4, 5, 6, 7, 8, 9. Sorry. Okay. So it's that top one. So one of the things you could do, if I wanted to find the midpoint of this, and this can get a little tricky, depending on the coordinates they give you, but instead of using a formula, if it's graphed, what you could do is count spaces. Now I can't count diagonally, but I could count up and down. This would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces up. And over, let's see here, 1, 2, 3, 4, 5, 6 spaces over. If you're kind of thinking of this in kind of terms of up and over. So to get from one to the other, you go up 12 and over 6. So if I want to find the midway point, the midpoint, it's literally half of those distances. So instead of going up 12, I'm going to go up 1, 2, 3, 4, 5, 6. And then over instead of 6, 1, 2, 3. And this would be my midpoint. Okay. Then I have to look at this and figure out, well, what coordinate is that? Negative 1, 2, 3, 4, down 1, 2, 3. Negative 4, negative 3. So that's another way to do this. Again, you could easily plug into the formula. And generally what I do is if they don't give me a graph, I don't graph it. I'm not going to take the extra step to go graph it and then count all these things. I could just plug into the formula. But if they give me a graph or it's already there, then I just jump right to the formula. Or sorry, right to the picture like I did here. All right? Now, this one's a little different, okay? And you got to pay attention to this on your homework, and if I give you a quiz or a test, like, read the words carefully, okay? On this one, find the coordinate of D if E is the midpoint. Wait a minute. Now they're asking us something different. What they are telling us is this. They want us to find the coordinates of this guy here. Okay, now I'm not drawing this accurately, but they give you the midpoint of the graph, and they give you one of the endpoints. So think of the formula for a minute. It said this. If I take the two endpoints for x, and I add them together and divide by 2, that will give me the x midpoint. And if I did the same thing for the y values, the endpoints added together divided by 2 would give me the y midpoint. In order, sorry, that should be an m. In order for me to have my midpoint coordinate. I'm putting little m's there for midpoint, right? So if I kind of solve this, I could do this. Right now it's a bunch of letters, but I could plug into all of these, right? The x1 and x2 stand for the endpoints. The xm is the midpoint. So let's kind of go through this. This would be the x midpoint. So I'm going to put a negative 6 here. And this would be one of the endpoints. Let's put it right here. But the reality is I don't know this other one. That's what they want me to find, right? They want me to find this d value. But I have a little equation here, and I'm only missing one thing, one variable. So I should be able to find that variable by solving this. Now watch what's going to happen, right? I would multiply both sides by 2. Okay. I'm going to erase the second one for a minute so we can kind of do our math here. My board does not want to erase right there. All right. So you got negative 5 plus x2 equals negative 12. And then I'm going to add 5 to both sides. All right. And you get x2 equals, that's a plus 5. I want to make sure. Negative 12 plus 5, negative 7. Okay. And that would be my x coordinate. Now this is up to you. I'm going to do the y value a little different. You could do this every single time. And the nice thing is, you already know the formula. If you've memorized midpoint formula, x1 plus x2 divided by 2, y1 plus y2 divided by 2, right? That's the formula. If you don't want to learn a new formula and you're okay to do a little more work of manipulating, you can do that. But the other way to do this is to take everything we've just done. Let's say I took this formula and we'll do it for y. For y, it's y1 plus y2 divided by 2 equals ym. let's say I wanted to take this and I wanted to just manipulate it to solve for one of these, and it doesn't really matter which one I solve for. Every single time, I'm going to multiply by 2 like you guys saw me do on both sides. And then I would, y1 plus y2 equals 2y sub m. And then I would subtract y2 or y1. It doesn't really matter. And so you end up with this new formula. You don't have to do this, but you can. If I'm looking for an endpoint, all you have to do is take 2 times the midpoint and then subtract the endpoint. So for us, in this problem, I'm going to take 2 times 4, 2 times 4, minus negative 3, or minus negative 3, 8 plus 3, and I'll get 11. That is the other endpoint. So it's negative 7, comma 11, and that kind of balances out. Now that's a little different, but it does work well. Okay. All right. So I want you to try this one. I want you to figure it out, and I think I'll, ask for some feedback on this one and see how we do and what we get. That's going to be the biggest thing. This is one of the hardest challenges for us, is figuring that out. Now, before I jump to the next one, they could also ask you about a quarter point, a fourth point. I want to make sure, think logically. If you think through that, you guys can solve that. If a midpoint is halfway, a quarter point would be, that's right, 1/4 of the way, right? So instead of x1 plus x2 divided by 2, it's x1 plus x2 divided by 4. There's some nuance and trickiness to that. We'll talk about that in a live context, but I want you to be aware of that as well. So give this one a try, and we'll follow up. All right, example number 5 says, what is the measurement of PR? So notice, first off, this is the answer. We want PR. If Q is the midpoint of PR. So what that means, if this is the midpoint, right here, here's the middle, I know that the distance here is the same as the distance here. Which means that whatever this guy is on the right, that's the same on the left. Or another way I could put that is 2 of this 6 minus 3x should equal the whole thing, 14x plus 2. Or I could do that a different way. I could say that one of the small ones is equal to half of the big one. Either way you want to look at it, okay? One is not necessarily easier than the other or better. Sometimes the math the way they set it up will be easier, but I could solve these fairly easily. I'll just take this one because it's on the bottom. So let's just take this 6 minus 3x. So these are 2 different options, right, that we could do. We're doing this one here. If I distribute my 1/2, you've got 7x plus 1. That 1/2 has to go to both, if you remember the distributive property. And now I'm solving this algebraically by moving things to one side, so plus 3x. And then minus 1. So you got 5 equals 10x. So x equals 5 divided by 10, or 1/2, 0.5. Okay. And I want to be careful, right? Really important. We are paying attention, and we're recognizing that I'm not going to put x as the answer, because that's not what they asked for. They asked for PR, and PR is this entire thing. Okay. Now, common sense, we're thinking carefully. If I plugged it in here, can I get my answer? Yes. If I do this, if I plug it in here, I just have to double it. And sometimes the math might be easier here than here. This one's not bad either way. Just depends on which one you want to do. I'm going to plug it in here. 14 times 1/2 plus 2 is 7. 7 plus 2 equals 9. So the entire thing is 9. If I really wanted to double check my work, I could plug it in here also and make sure that I got the same answer. Yeah, this should end up being, QR should be 4.5. Exactly half of 9. If I don't get that, I did something wrong in my math. All right? Hopefully you can see that one's not too bad. Just, again, requires us to think a little bit. All right? So this one, notice they tossed a 1/3 in there. It says, find x on CF. Here's CF right here. That is 1/3 the distance from C to F. So let's figure out the distance. We can just count these. This is pretty easy. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's 9 spaces. So if x is 1/3 of that distance, we want it to be 3 spaces. So I would count over 1, 2, 3 spaces. 1, 2, 3, and I would be right here. And that would be x. Now, I want to be careful. It says find x on CF. That is 1/3 the distance from C to F. Now, this is 1/3 the distance, but it doesn't necessarily say I have to start at C. Okay? Now it says from C to F, so I would be inclined to do this, but I want us to also see that I could have gone the other way, 1, 2, 3 spaces from the other side, and I could have put an X here. Hopefully we see that, and that's why I said there's a little nuance to some of those problems that are like, what if 1/3 or 1/4? And we'll talk more about this later, again, in a live context. But I think that's enough to at least get you thinking through it. Generally speaking, I err on the side of what they tell me. If they say from C to F, then I think starting at C going over 3 spaces, right? 1/3 of 9. But there's ways that they could word that a little differently, and I just want to make sure that we're careful in thinking through those. All right, so we'll take a look at those again as we get together in class. All right, hopefully that's helpful. Again, always just looking at enough to get the ball rolling, get you guys thinking through practicing some things, and then as you have questions,